All right. Hello, everyone. We're live. I'm just going to give people a minute more just to get into the room. Feel free to drop in the chat where you're joining from today. It's a beautiful day up here in Montreal. Good to see so many people dropping in already. We've got lots of folks coming through. Nice. St. Louis, Edmonton, South Texas. Love to see it. Oh, UK. My motherland. Good to see you, Jakob. All right. Well, I think I'm just going to get started here. So thanks for joining us, everyone. Welcome to this MaintainX Masterclass. Really good to see so many of you coming through. Today's session is all about how we can use live machine data to drive our maintenance strategies. So it's obviously a really key part of the Industry 4.0 movement, and it's also an important step for any company that wants to just become more data driven. There are obviously a lot of challenges putting this type of stuff into practice. So we just want to help you today, whether that be to kickstart a project like this or maybe get an initiative that you already started back on track. I'm sure some of you are also just here to see what's possible. So I'm confident that we'll be able to give you some ideas there and hopefully some practical steps as well that you can take back to your teams. So a bit of housekeeping before we get in. This webinar is being recorded. You're going to get a copy straight to your email inbox later today. And I would recommend as well, if you find it useful and there's coworkers over there that you would find it interesting as well, please do forward it to them. If you have questions throughout the session, you can go to the Q&A box on the right side of the screen to submit a question. Please do try to use the Q&A for the questions and not the chat, just because we've got some team members on the line here to answer them for you, and they're going to be monitoring that box specifically. So my name's Colin. I work in product marketing here. I'm responsible for bringing our asset intelligence solutions to market. So a lot of that's focused on the various ways you can get machine data into MaintainX and how you can use it to drive more effective day-to-day maintenance. Happy to be joined as well today by Kyle, our solutions consultant. So Kyle, how you doing, buddy?
Great, Colin. Really happy to be here. Excited for the conversation. Yeah, my name's Kyle Beers, solutions consultant here at MaintainX. I've been here for about a little over a year, close to a year and a half now, I should say. Actually started my career in the manufacturing environment. So really enjoy having these conversations with folks that have gone through similar struggles or have similar goals. Um, really into reliability and machine health. So really ties nicely into the conversations about getting all teams connected here and PMs and a lot of the fun topics we'll cover today. And then really my job here at MaintainX is working with our customers to see what we can do to help them drive digital transformation using our products. So nice to be here.
Yeah, thanks, Kyle. Good to have you here. So before we get too technical with this stuff, I did just want to take 5 minutes to kind of briefly introduce today's discussion and why this all matters. So most industrial companies are on this sort of journey today. If you're watching this, if you're attending this webinar, you've at least started moving away from paper and spreadsheets. It might be that up to this point you've been focused on digitizing your records, capturing better data from the shop floor. For other folks on the call, maybe you're already doing some condition-based maintenance with or without sensors. But I think everybody is more or less moving in the same direction, right? We all want to be smarter about preventing breakdowns. We want to be more proactive. We want to make our operations more predictable. And there's so much technology and strategies and advice out there that we can't bite it off all at once. So what we're mostly focused on today is this middle stage. So when you've taken some steps as an organization to start capturing data in digital form, whether that be through sensors or PLCs or just through a work execution platform like MaintainX, how do you connect that information to make it more useful? And this is a really critical step on the way to those more advanced predictive and prescriptive strategies that we see some companies overlook. It's if you've invested in SCADA systems, sensors, predictive maintenance solutions, these are all really great steps forward. But at the end of the day, those systems are only truly useful if the data is getting to the right person at the right time, the person who's actually going to intervene and do what's needed to keep the lines running. And of course, when systems aren't connected, this is how it hurts the bottom line. For one, there's more downtime, either because you aren't catching those issues soon enough, or the person tasked with fixing the issue doesn't have the information they need close to hand, something that we often see. you're also likely to spend more time to spend more doing the work. And I don't just mean the reactive work here. There's also preventive work that maybe you don't need to do if you could avoid doing it by having more insight into the health of your equipment. And then there's also the people aspect. You know, your most precious resource is your people. When they don't have the data to do their jobs, to plan the work, to execute the work, then you're most likely not using their time in the most efficient way. And this is increasingly important because, you know, firstly, we're seeing downtime costs on the rise. This was a really kind of alarming thing that came out of our state of industrial maintenance this year, was that the cost of an hour of downtime is continuing to increase. So the cost of missing a signal or missing an alarm is now higher than it's been before. We also know that skilled labor is a really scarce resource. You know, we don't have time to waste reacting to incidents and gathering information about what the problem is and what we did last time, and a lot of that kind of back and forth that happens when you don't have connected data and automation. And there's also so much new technology that's available to us now. When you think about AI, automation, obviously it all thrives on data. So it's really important to start now building that foundation of data that will enable much smarter, much more advanced maintenance strategies for you in the near future. And the companies that are taking advantage of this are seeing some strong outcomes. You know, doing the right maintenance at the right time reduces that reactive firefighting and unnecessary preventive work. It also prevents breakdowns, reduces downtime overall, and that, of course, has a major impact on production. But you know, putting all this into practice, it obviously comes with challenges, both on the technology side and in terms of company culture and communication and all those things that we can't overlook. We're going to do our best to help you with both of these today as we walk through those things. Kyle, you know, again, great to have you here. Just starting with the tech, I know you work with teams every day, and the tech stack looks a little different from place to place. So could you just explain a little bit about like where this machine data lives and how we actually connect?
Yeah, absolutely. And I think this ISA 95 model does a really good job at explaining that. Um, for those who haven't seen this, this is really what I think of as the structural backbone for integrating our top level business systems with our lower level manufacturing systems, that machine level shop floor data. And really why this is significant is that when we think about connecting to this data, there's a distinction that needs to be made. And the context goes up as we go up from level 1 to level 2, right? A lot of what we're talking about today is going to be capturing PLC data. Well, where are we capturing it from? Directly the PLC? Well, we'll find that there are some, technical requirements. There's things that our customers are starting to think about when they mature with their digital transformation into getting that data network, bringing that to that next level. And as this pyramid goes up, we add more context and really understanding this. And, every manufacturing environment should have a good understanding of what this looks like for their facility. So I think it's really important that we just kind of touch on it. And Colin, if we want to go to the next slide here, we'll talk a little bit about how are we actually connecting to this machine data, right? This is really a large part of why we're doing this having this conversation today is that I have PLC XYZ, I have this system, I need my data in MaintainX to make better decisions. And so excuse me, this does a really good job, I think, of kind of outlining that, right? So we're looking at the equipment on the left, the sensors, the PLC, that level 0, that level 1. Now, what MaintainX has helped build is, um, you know, if this data is networked, that middle bucket, getting this data networked and utilizing key systems or protocols, which we're calling our OT connectors, right? These three different connectors that we're going to make this possible with. So I'll give a quick highlight of what they are. The first one we have is called Kepler. So really what this is think of this as a universal language translator for PLC data. It's going to aggregate your data from legacy protocols, right, and have that much more legible so that we can then bring that into MaintainX. The next one, which I'm hopeful lots of folks are familiar with, is Ignition, which is a very robust SCADA system of which MaintainX has built a module directly for that, allowing for another very seamless integration. And the last one, MQTT. This is really more of a protocol. We'll find that many devices and systems have the ability to communicate over MQTT, And what MaintainX offers is the ability to deploy an on-premise agent to communicate specifically to a MQTT broker. So I just wanted to kind of break that down because a lot of the conversations that we're going to have today revolve around utilizing these OT connectors. So I wanted to give a strong foundation as we go ahead and open up for these questions. Anything to add, Colin, before we go ahead and dive in?
No, I think that's good. I think that's a really good intro. And yeah, we didn't want to hammer you with slides today. We wanted to address some of the questions that were asked before. So I'm going to actually stop sharing my screen, and I think Kyle, do you have any over there that you can kind of start popping at me?
Yeah, absolutely. So I think the first couple questions are related here. The first one says, how leading teams are using machine data to prevent failures and improve efficiency.
Yeah, and it's a good question. I think it's a really good place to start actually. I think leading teams makes me think of companies that are furthest along in their maturity and or already have put, predictive maintenance into practice. But I actually think that there's a whole spectrum of use cases, right from something as simple as just automating your downtime tracking up to things like condition-based maintenance, which is really impactful in terms of preventing breakdowns. I'd say what I see leading companies doing is adopting more advanced strategies a bit at a time. So starting with their most critical assets, I'd say the companies that are doing condition-based maintenance are seeing some of the best results in terms of failure prevention because they're catching issues and acting on them quickly. And there I'm thinking along the lines of triggering work orders automatically when there's something like a temperature or a vibration reading that's exceeding what it should. But I would say some of the more straightforward use cases are yielding really great results as well. And I believe that just being able to benchmark normal machine behavior is a really big early win. So it sounds simple, but just tracking the on and offline status of a machine and having that information close to hand in your CMS is going to give you a really good sense of how that machine is performing and what it's likely to need. Building from there, you can then start to track your MTBF, mean time between failures. It's going to help you to get more precise on when to schedule PMs. And then I would say that it also helps you to spot to know what an anomaly looks like, right? So when you're thinking about building a condition-based maintenance program in the future, I think trying to jump ahead to that before you really understand what the most common issues are for your machines doesn't always pay off. So, I can't stress enough the benefit of just having that data flowing into MaintainX for visibility, even if you're not necessarily ready to set up automated workflows yet.
Yeah, all good, great points, Colin. And one thing I'll just kind of build off that is the improving efficiency. Where my mind goes for all of our MaintainX users, our labor efficiencies are much better because we're identifying and communicating problems quicker. Well, it's getting that much quicker by giving visibility into a lot of this machine data to our maintenance personnel, to the folks on the floor that need to be made aware of this and actually doing the work.
Yeah, and we actually got a few questions on this that are fairly similar. That are people are trying to understand what PM looks like, how PM essentially evolves when you start to bring data in or start integrating automations. There's a question here that just says, I'm interested in learning more about preventive maintenance through integrated automation. Any thoughts on that, Kyle?
Yeah, and this is definitely different cross industry, but I'll start with kind of the first part of that question, which is learning about preventative maintenance, and then we'll get into kind of the integrated automation. There's a reason for that. And I think when folks think about PMs, we're thinking pen and paper on a schedule, based on calendar based. We're finding that trend is changing, obviously, to a more usage-based things that are going to be driven from data. And so we always like to say, or I like to say, like there's really a good, a better, and a best, right? We have our calendar base, which a lot of our customers are doing, and we're moving into more of that. We'll call it usage based, right? Our runtime hours. How many cycles before I need to service something for some form of wear component. And then what we're unlocking even further is going to be that integrated automation piece. So now I'm getting condition-based data from my machine, that temperature data, that vibration data. I'm able to go ahead and then set up the proper automation, really that work order creation, that notification of which without these connectors, without that integration, that maintenance personnel is never going to know that might stay siloed, locked at that machine level.
Yeah, and there's an opportunity to save money here as well, right? I mean, by trying to reduce some of that PM work that maybe is not optimized, I was speaking with a customer recently that is setting up our MQTT connector. They were doing calendar-based PMs, and there were machines that would sometimes be switched off for several days in a row. And so they didn't have a good system for adjusting those calendar-based schedules each time the machine had been out of service. So what they're doing now, they're pulling that runtime information through from their MQTT broker. And the way that they have done it, one question I often ask these customers is, how are you deciding what runtime thresholds to use for those PMs? Sometimes they're getting that from the OEM. But what you can do is a really simple starting point is really just take the interval in hours. So a 2 weeks is 336 hours. Set that as your usage-based PM instead of a calendar-based 2-week PM. And then, obviously goes without saying, if that machine is out of service or not operational for 4 days, it's going to push that next PM back 4 days automatically. So I think that's a really good starting point. And then obviously once you have more reliable data on things like your MTBF, your mean time between failures, you can then start to build from there and start to use some of that information to determine more accurate usage thresholds.
Yeah, I'll go ahead and I can go ahead and read this next one here, Colin. I
Okay.
think it's kind of all heavily related. We're kind of just maturing through this journey here. This is really about predictive measures. So what kind of predictive measures should we take to reduce downtime?
Yeah, I think the first step is visibility. I'm just thinking about where a lot of people are today, and we often get asked a lot about predictive maintenance and kind of how we support it and that type of thing. And I think really the first step I would say is about visibility. It's all about, even if you don't have the automation in place yet to act on predictive insights, I think centralizing your machine data in a system like MaintainX is going to help you to spot things that look off. So I feel like a predictive measure is trend analysis. That's one thing. Before you start using AI and things like that, you're just making it easier for yourself to catch a fault and act on it because you've got this data coming in that's reliable in real time, and it's helping to improve your insights and your reporting. I think
Yeah.
also just accumulating data is a predictive measure as well. You might not necessarily have the means today to derive really accurate insights out of that automatically, but you're starting to generate a bedrock of information that's going to help you to take advantage of that type of technology in the near future.
And I think making sure you have those foundational blocks that's going to, if we're asking about predictive maintenance, we want to assume that that data is it's connected, it's collected, it's visualized, it's stored. It's all of those things that are going to allow us to assess and reduce downtime from a machine standpoint, right? I'm understanding the machine condition and then effectively adding that context from things that already exist in MaintainX, right? When we think of that ISA 95 pyramid, if we're going to be predictive, we need to add context from these different layers, from that MES layer, from that machine layer, from the work order execution layer, at its core with MaintainX. So, yeah, really good question. I think predictive maintenance is on everyone's mind, and it's really a journey more than, hey, install this and you're good to go. I can go ahead and read this next one here as well, Colin. So this one, getting a little bit more specific now, ignition-based question. We have ignition as our SCADA system. How does that integrate into MaintainX for real-time data? And is it possible to trigger automatic work orders for failures? If so, how?
Yeah, so if you're using Ignition, we actually have a very streamlined system for getting that data into MaintainX. We've just, as Kyle kind of introduced, we launched a native connector, so that connects directly to your Ignition instance, and it's very quick. You don't need to build anything on your end or use the API to get that data into MaintainX. It's really very simple. And to answer the second part, yes, you can trigger work orders using Ignition tags. When you connect the two systems, you can choose tags from Ignition that you want to import into MaintainX, and then they'll be kind of automatically updated as meters inside MaintainX. And then what you can do is you can use our automations module to set up usage-based or condition-based thresholds based on those tags. So think about, I don't know, triggering a PM for a wrapper machine every 100,000 cycles or something like that. That's information that's coming from your Ignition tags, and then you're setting up the automation inside MaintainX to trigger a workflow, whether it be a PM or an inspection. And so, yeah, you're basically getting that Ignition tag data into MaintainX as meters, and then you can use that to automate not just work orders, but also email notifications and asset status updates in MaintainX as well.
I'll keep you going on that thought, Colin. The next question is actual examples. Any examples of Ignition communicating with MaintainX through our customers?
Yeah, good question. And we do have customers already using this connector for various things. One would be automated downtime tracking. So again, it's kind of the most straightforward use case. You're literally just getting that on-off status into MaintainX in order to track downtime in the system. So I'm thinking about, we have an infrastructure manufacturer working with us that reduced downtime on one of their most critical assets by I think 57% year on year just by having this visibility. So I think how they were doing it, first of all, it helps them to acknowledge an issue and move faster, and it's something that Kyle touched upon earlier. And then secondly, they're able to generate downtime history on the asset that's real time. It's super accurate. Help them to identify their bad actors and invest in areas like doing adjusting their PM plan or investing in operator training or things like that. Now they're looking into setting up more usage-based, condition-based thresholds to try and reduce that downtime even further. So I mean, that's another example Kyle touched upon about kind of good, better, best, kind of moving through the journey there to unlock more use cases. And then we also have customers that are doing condition-based maintenance using Ignition and MaintainX. So I'm thinking of one here that has vibration sensors that are networked with Ignition, and they're triggering PMs and inspections using the work order automation that I spoke of in MaintainX. So again, these are just triggered in the same way that a meter triggers already worked in MaintainX. The only difference is that your meters are now being automatically populated with that real-time data that's coming straight from Ignition. And actually talking of the Ignition connector, I'll ping this one back to you, Kyle. So how does the connection process work? This was another question that we got.
Yeah, this is a really good question, and there's some really great content on how to set this up. As I may have mentioned, these are going to be customer-led integrations where MaintainX is providing that connector, and you are able to generate that instance, use that authentication token, and go through the set of instructions that we do have available. And I'll actually just kind of share my page here real quick, just to kind of because I think this is something that I want the folks to reference here um, uh, after the call, and I think we said we will go ahead and drop this link as well. But the idea here is that we want to make this as simple as possible. So each and every um, connector has its own set of instructions where it's going to go through what are the minimum requirements, right? So it's a lot of times what happens is we get questions on how to set this up. And sometimes our customers will have the pieces in place to go ahead and purchase this connector and hit the ground running. Other times, we're going to need to reference this material to make sure that we're meeting those minimum requirements. And from there, the instructions are there to go ahead and set up each and every connection. And what's really nice too, we made that available, and we can view the status of each and every connection directly in our MaintainX organization here. So we do have an integrations dedicated page that we can go ahead and monitor the status of each and every connection. This is where we're going to go ahead and create our instance, auto create our meters if we so choose, generate that token. And what's really nice too is we can see, hey, how many meters are connected? Are we getting that expected result? Trying to remove barriers from troubleshooting when it goes to setting these up. So like I said, we have a help center to walk through this. We try to make it as easy to follow as possible. With that being said, we do have resources on hand to go ahead and help with that. But strongly encourage folks on the call to take a look at this help page, go through it and ask questions where needed. Ask questions internally as well. Hey, do we meet these requirements? Are we able to set this up and start pulling in data?
Yeah, and I think one of the things you'll have noticed on the integration tile as well, we had Kepler on there. That's something that we haven't really spoken about yet. We did have a question from somebody that says we're in the process of integrating the MX system with the MaintainX system with Kepler and looking for some insight or best practice to kick this off right. We've been using MaintainX for about a year now. Kyle, you got any insights on that?
Yeah, yeah, similar to our other talk tracks, right? Start simple. If it's more of the technical, how do I do that, right? We're also working with the assumption that you have that IoT gateway plugin for Kepware in order to effectively connect to that data. But yeah, start small, right? We don't want to get overloaded with data, especially if we're auto creating all of our meters. We want to go ahead and pick those examples, those data sets that are going to be important, not just for our production folks, our operations, but also maintenance. Um, One practical approach that I like to take is, again, start with those usage base, those hours, those status. Start gaining visibility to our maintenance personnel. It's going to bridge the gap. It's going to have people just talk more. It's going to allow you to troubleshoot more. But again, start small. Pick one or two pieces of equipment that you know is troublesome, that could use some visibility from maintenance staff, and expand from there.
Yeah, and I think doing that type of pilot program helps you also to get buy-in from other folks at the company when you're ready to roll it out wider. Like if you can even show that run hours are successfully triggering out PMs, and it's going to inspire some confidence, and then you can share business impact once you start to see it. So, things like reduction in downtime, fewer faults, faster MTTR, which is typically what we're seeing when you have machine data coming in real time. Just make sure that you're measuring these things, you're capturing them, and you're kind of communicating them back as well. Um,
Absolutely.
So there's another question here, a little bit more specific about our automations. It says, can we create multiple notification thresholds for the data trends? So for example, you would have low, 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 high, and high, high. So kind of like different tiers of notification.
Yeah, another great question. So I'll reference when we say automations, MaintainX has a module, our automation engine, that's going to effectively take you through an entire workflow based on meter values. So the short answer is yes, we can set up multiple automations with different triggers and also have different actions that come from them. Um, Basically, what's going to happen is your data, your tags are going to come in as MaintainX meters. You're going to set the condition, define the criteria, and then once that condition is met, you're going to trigger actions. And the nice thing about this, you can have multiple different actions, so you can layer these. Right? If I have a low alarm, and I just need that to go to my operator, versus if I have a high alarm and I need that to go to the plant manager via an email, we have the flexibility there as well.
Yeah, and then a similar one here about this functionality. Will it monitor based on statistical criteria? For example, X bar and R charting with statistical off-trend detection.
Yeah, this is another really good question. Right now, our automation engine, where we're going to go ahead and put in those values, is user defined based on that value alone. Something potentially in the future here for MaintainX is to look at the different statistical models that we could go ahead and apply to data sets. Um, we have spoken to other customers about performing that calculation elsewhere in a respective that respective system, and then pulling that in as its own data tag. So not right now. It's going to be user defined values from those data tags. I'll go ahead and read this next question. What is the best way to integrate automated machine run hour reporting into MaintainX?
Okay, yeah, so that's going to depend on obviously what system you're using at the moment. If you have those run hours in Ignition, Kepware, or MQTT broker, you can obviously use our native connectors to get it into MaintainX. Optionally, we have the API that can be used to build integrations with other IoT systems. And then I think once you have those run hours coming into MaintainX, you're going to have all that data in your run hour meters that are going to be attached to your asset, and you can obviously use that to trigger usage-based PMs. But if you're just looking for the reporting on there, you can access run hour analytics via your meters. And then also from the reporting standpoint, you can bring in like I mentioned earlier, you can bring in your online offline status into MaintainX, and that's going to give you an accurate picture of when the machine was operational versus not. It's also going to populate your asset health dashboard with really strong real time status hours in there as well. I got a question here for you, Kyle. Have you got a guide for setting up the MQTT broker and the MaintainX Docker interface?
Yeah, good question. One that we get a lot with this MQTT connector. We are assuming that the broker is in place, right? So your organization does use a MQTT broker. We'll act as the client and subscribe to that data using our on-premise agent. So uh, we can provide technical support to kind of if you are having trouble setting this up. But what I would also say is, um, the instruction set in order to do that is going to say, hey, what are my minimum requirements? And one of those is that we do have an MQTT broker in place. We can help. There's plenty of references online as well as what brokers are available. What we find, a lot of our customers have the ability to communicate via MQTT, and they go, okay, now what broker should I use? And so there's lots of information available in order to help choose that. We want to encourage and enable everyone to keep transforming digitally, keep maturing through that. So we can definitely be a resource to help answer that.
Yeah, and there's a quick follow-up to this one, which is what protocols are required used to read data?
Yeah, another good question and important distinction here. When we talk about protocols, we're talking about industrial communication protocols, which you've heard me refer to MQTT as. Um, when we look at the three connectors in total, we have Ignition, Kepware, and MQTT. It's important to recognize that Ignition and Kepware are native integrations, so directly with the system, versus when we think about the MQTT connector, it's going to be directly through the broker from something that uses the MQTT protocol. So it's almost, there's an extra layer in there, but it is an important distinction. As I mentioned, a lot of devices, PLCs might be MQTT native. There has to be something that acts as a broker in order to access that data and subscribe to that.
And then another one here, are IoTs required at all stages of connection?
IoT is required. Okay. Yeah. So I'll answer this question two ways, depending on what the asker meant here by IoTs. The way I would best answer this is, if you have data in an IoT platform, that's something we would likely integrate directly using the API. As I just mentioned, though, the connectors we built are going to allow you to integrate with the existing systems that have PLCs or machine level data ready and accessible. I also just want to kind of make a quick note here that, with these connectors, whenever I see the word IoTs, I do hear folks reference them hardware. So there is no hardware involved, with these processes.
Thanks, Kyle. So I think we're almost through the questions that we had pre-submitted to us. Um, I do think a good way to wrap this. There is a question here that I think is a good way to kind of wrap this. Obviously, we've spoken a lot about the benefits today of integrating this data and setting up automations and the types of strategies that it enables. But I think there'll be people, thinking about how do they actually drive this forward in their organization, given that there are quite a lot of different people in different departments that are going to touch various parts of this. So the question specifically is, how do I scale this and show leadership the benefit? Any thoughts on that?
Really good question. This is something that, like I said, we need to start talking about a lot within our facilities. Is that interoperability, that cross functionality, and to that we have to have a common digital transformation strategy, which falls is often come up in these conversations. And the best way to do this, I think it's something that we can use based off real world examples. And one that really comes to mind to me is, whenever there is a breakdown and we have to investigate it, we have these siloed departments investigating things that are really in their wheelhouse. Maintenance might call a controls engineer and ask them if there was any data from the PLC. And too often, at least in my experience, there was simply no visibility. And to me, that speaks volumes in itself. Could it be prevented if that data was accessible to maintenance and could have investigated something? So really, start by looking at past failures, places where there may have been signs, data that has been kind of locked away, and perhaps we can increase that visibility.
Yeah, that's a great answer. All I would add is, yeah, I think you touched upon it well, but like different teams, obviously they don't always speak the same language, but they're often working towards the same outcomes, right? So I think making it an ROI driven initiative from the start, um, yeah, making it more than just an IT OT initiative. It's really about business continuity, right? So bring together those shared KPIs, show the improvement it's going to have on uptime, and then try to prove the improvement there as early as you can. We've
Mhm.
mentioned a few times in this session that connecting this data in and of itself makes it easier for you to track and highlight those things like downtime and averted failures. Those are the things that really impact the bottom line. So I think showing those numbers will help to satisfy some of the skeptics, and it's obviously going to resonate with the, from controls engineers up to plant managers. They're going to understand how this is actually helping them to drive towards the goals that they have as well.
And I'll just add, Colin, ask questions to us. One of the things that we see a lot is that we hear the word integration or OT/IT connection, whatever it might be, and there's a bad connotation with this costs a lot of money, this is timely, and I don't have the resources. Um, when I speak with our customers and folks that see how these connectors work, I think they're very surprised that it takes minutes sometimes in order to get these established. So use that as a way to communicate between the different departments in your organization to uncover is there important data that we have living on our machines that's could be generating some value.
All right. So I'm just gonna reshare here for a second. All right. So we've got a little bit of time left here for some live Q&A. I think there's a question here. On average, how long does it take to build a decent data model once you get your sensors pushing data to MaintainX? Can you got to answer for that one, Carl?
Yeah, certainly. I think one thing to state here is that currently with MaintainX automation engine, everything is going to be controlled based on some form of a threshold value from that data. One thing that we're working towards, just like everyone else, is predictive, right? And so when we think about models, we think about adding that context. We think about statistical models that was asked in that question. And so I don't have an answer for how long it takes to build a decent data model. What I can say is that we can visualize the data inside MaintainX, and that is something that a lot of times we fail to recognize. And with that, we're starting to view behaviors of our machines over time using that. And as our product improves here with data modeling, I'll come back and answer how long it took. But I think a lot of this has to do with kind of baselining and a lot of condition-based data versus usage. So good question. Definitely interested in who asked this question to speak to some more.
And then we've got another one here. How do we simplify integration of PLCs from HMI UI customization to data analysis and reporting without a full-time controls engineer maintaining the system? Are equipment OEMs working towards this?
This is a really good question and a tough one. And I just want to reword it for everyone here too. If you have PLCs in your facility and you're not managing them, it can pose a challenge with doing that. A lot of times, we will invite whoever that contractor, that consultant is, to come in and help. But a lot of times, I think depending on any barriers in place, that if we can get over the barriers, with that OEM, then we can all work together in order to do this. And truthfully, if the bandwidth is there for our customers to take some more ownership over their controls, over the PLCs, it's going to make it that much easier. Yeah, it is a difficult scenario though, for sure. But talk with us. We can help you relay the messaging in a way that's going to, like I said, not make it intimidating when we're talking about integrating this data.
All right, there's one here I'm going to take a stab at. I'd love it if our if our CEO or head of products was here. But the question is, can you talk about the future of this space? I recently heard the chairman of Siemens speak about how machine language models are being developed similar to large language models, LLMs. Machines would then make inferences or think for themselves based on these trained machine models and make modifications or do maintenance without necessary human input. Any thoughts on this? Wow. I mean, I think it's an interesting question, and there's clearly a lot of innovation happening with AI and large language models at the moment. I think we're at the point where we really believe in the interoperability of systems. We think it's critically important, but we also know that we want to make all of that information actionable. So I think what we're doing is we're trying to create intelligent systems that take asset intelligence and also the work intelligence that's provided by the technician, and then create a system where holistically right across the maintenance journey, there's AI and intelligence that's helping people to do their jobs better across that journey. So I think there's clearly a lot of space there to, you know, suggest which PM should be done, who should do it, make some of those, help people make those prioritization decisions. I think right now we're not necessarily, or at least I don't see it necessarily with where we're going as the machines thinking for themselves. It's more about we know that the people are going to be critical to the operation, and we just want our technology to serve insights to them in a way that's as actionable as possible. Helps them to upskill and become more proficient and essentially able to work smarter and faster on the job. That's kind of how I see it.
Well said, Colin. I do see another question here. What kind of data connector can be used? Also, what about equipment that does not have a PLC due to its age? Yeah, really, really another good question, something that we hear a lot. The harsh reality is the data needs to be networked in some fashion in order to access it and have that inside of MaintainX. And so what we have noticed, some options. I don't have the slide in front of me, but when we went through that diagram that showed how we connect to a machine, we do have other integration services available. We have our API. We have systems integrators that we can work closely with. But in reality, the thing that would make most sense and for scalability is going to be to retrofit that with some form of PLC controller, something that has the ability to communicate, perhaps even natively, with MQTT. A lot of newer equipment does have that ability. So, my best advice would be look towards networking that. If not, IoT devices are something that are certainly popular and can be accessed over the cloud.
All right, thank you, Kyle. Any more questions here? I know we've answered a few of them live. I know our team has also been busy in the Q&A. Just gonna give it another few seconds here. Okay. Well, I really appreciate everybody's attendance today. I hope it's been useful for you. Like I said, you will get the recording in your email inbox. I just wanted to, before we jump off, share a few important links with you as well. Remember that we do have the MaintainX Academy. There you can find certifications, guides, courses that are going to help you to level up, not only in using the system, but also in your maintenance strategy overall as well. We have the MaintainX community. So there's already other members of MaintainX, other customers of MaintainX in there that are sharing best practices and tips for maintenance strategy overall, but also for how to use the system. And I think it's a good place to go to get inspired. And then obviously, finally, if you are not yet a customer of MaintainX and you'd like to speak to somebody for more information, you can click the button right on the screen, and we'll schedule some time with an expert for you. So I think that's it. Thank you so much for attending again, and we will see you at the next MaintainX Masterclass.
Thank you, everyone.